Welcome, 8th grade, to our first video lesson of the year. We are starting the year with the study of integer exponents. Now, these are two words that you've heard before, but now you're using them together. And so let's just review. The word integer refers to any whole number and its opposite. So whole numbers are 0, 1, 2, 3, 4, 5, and on and on. And their opposites, there's not an opposite of 0, but the opposite of 1 would be -1. Positive 2 has an opposite of -2. So those are integers. Exponents is something that we have heard before, and we're going to just review quickly how we've used exponents up to now. So over the years, this has been the progression of how you've heard exponents. In 5th grade, we talked about powers of 10. So if you remember, we said 10 to the second power means that 10 is a factor 2 times, and that's value is 10 times 10, or 100. In 6th grade, we changed the basis to be numbers other than 10. So we might have said 2 to the 5th power, and what that means is 2 is a factor and it's repeated 5 times. So 2 times 2 times 2 times 2 times 2. So this form, 2 to the 5th power, is exponential form. This 2 times 2 times 2 times 2 times 2 is expanded form. And the product of all that would be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 32 would be called the product. So that is how we used exponents in 6th grade. And then when you got to 7th grade, we actually used exponents as part of formulas when we were looking for area of a circle and for volume. Now, what happens in 8th grade is that the standard we're working on says that you will know and apply the properties of integer exponents to generate equivalent numerical expressions. That means we're going to find ways to express two quantities or two expressions. Now, properties means they're sort of like rules, and we're going to learn the properties of exponents. All right, so let's start by looking at patterns. And this screen doesn't look great, but what I'd like you to do right now is pause the video and find the value of each of these exponential notation quantities. All right, so hopefully you saw that there was a pattern happening here. If you start with the first power, that's always the simplest one. 2 to the first power is 2 because 2 is a factor one time. But 2 to the second power means we're using 2 as a factor twice. So 2 times 2 is 4. 2 to the third power means we're going to use 2 as a factor 3 times. 2 times 2 is 4, times 2 is 8. So every time we move up in this, oh no, I lost it. There we go. Every time we move up, we multiplied by 2. And in this case, this first column is because we're doing powers of 2. These are powers of 2. Now, in the next column, though, we're doing powers of 5 because 5 is the base. That's the number that we're repeating as a factor. So powers of 5 increase. Every time the exponent goes up 1, we multiply by 5. And in powers of 10, 10 is the base. So these are powers of 10. And every time we increase the exponent by 1, we multiply by 10 again. So 10 to the 5th power is 100,000 because 10 times 10 times 10 times 10 times 10, using 10 5 times, is 100,000. Now, you may remember from 5th grade, there's a correlation between the exponent and the number of zeros. So 10 to the 5th power, 5 is the exponent, and there happen to be 5 zeros in that product. So we're going to look at how to notate exponents because sometimes the exponent is going to be rather large. And also the base doesn't have to be a whole number. Right now, all the examples we've used, we've had powers of 2, so 2 is a whole number, powers of 5, 5 is a whole number, powers of 10, 10 is a whole number. But the base doesn't have to be a whole number. It could be a negative number, it could be a fraction, it could be a decimal. So we still handle it the same way. So whatever, and it also could be a variable. So let's say we had x as the base. X is an unknown. X represents an unknown quantity. And let's say n is the exponent. Don't know what that is, but we can still know that whatever x is, we're going to repeat it as a factor n number of times. And the way that we show this, and you can see this right here, is that we're going to do this sort of dot, 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 means it just continues on. We're multiplying x times itself, however many times of n. Okay, I know that seems kind of generic right now, but it'll make more sense in a moment. So here's an example in this number 1 here, is that 7 is the base and n is the exponent because we don't know what n is. We could write this. Now you'll notice here our materials are going to use a multiplication sign that looks like an X if we're dealing with numbers. But if we're dealing with variables, then we're going to use dots, okay? So n to the 7th power means 7 is being multiplied however many times of n. And this is how we would notate it right here. Okay, so now 4/5 to the nth power. 4/5 is a fraction, and so whenever we put a fraction as the base, we're going to put it in parentheses because we want to know that that whole thing is part of the base. And again, we can show 4/5 times dot, 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 because we don't know what n is, and we indicate the exponent here just as a notation. Okay, when we have a negative quantity, we're also going to put that in parentheses because that negative is part of the base. And so whenever we have a negative quantity, we also want to have that in the base. And the same thing, we don't know what n is, but we will indicate that here, that is just an unknown, but we know that that's the number of times that that -2 3/10 gets repeated. So I'm going to ask you to pause the video so that you can do these 10 problems. So some of them ask, for instance, number 1, you need to write this in exponential form. But on number 2, you need to fill in the blank of how many times is this factor repeated. Okay, so pause the video, do these 10 exercises, and then come back and check your work. Okay, so take a look at how you did. Important things to remember is that if your base is a fraction or is a negative, it needs to be in parentheses, okay? Only positive integers and variables don't need a parentheses, okay? So again, pause the video, check your work. Okay, so now we just want to think about the values of these expressions. So if we had -1 to the 12th power, I want to think about whether that product is positive or negative. So what does -1 to the 12th power mean? Well, we're going to multiply -1 times -1 times -1 times -1 and on until we've done it 12 times. So positive or negative? Well, let's do, also want to think about what if we did it 13 times? What if the exponent was 13? Now, one of these is going to be positive and one's going to be negative because if you remember, a positive times a positive is a positive. A negative times a negative is also a positive, but a negative times a positive is a negative. So which is it going to be? Well, anytime you have an even number of negative factors, the result is going to be positive because a negative times a negative is a positive. So if you multiply 2 negatives and got a positive, and then you multiply by a negative again, that would make it negative. So the difference is if it's a positive exponent, it's going to be positive. If it's an even exponent, it's going to be positive. If it's an odd exponent, it's going to be negative. So you can figure this out without actually doing any multiplication. So here we go with two additional problems. The question is, will the product be positive or negative? So if we have -5 that we're going to multiply by itself 95 times. So this is how you would write it in exponential form. This is how you would write it in expanded form. 95 is an odd number of factors. So if you have an odd number of negative factors, the result is going to be negative. In this case, where -1 8/10 is being repeated as a factor 122 times, 122 is an even number. This means this would be a positive product. Okay, let's complete these two statements about n. So if n is a positive even number, then -55 to the nth power would be positive or negative. Well, it's an even exponent. That means the result would be positive. And if n were a positive odd number with a negative base, a negative times a negative times a negative, an odd number of times would give us a negative result. So that is lesson 1 on integer exponents. There's more to come, but you have some practice problems to work on. And I will see you on Zoom tomorrow, and we will work on this a little bit more. Have a good day.